Yeah, I think the Internet of Things is the second major revolution in the Internet. And I think in 10, certainly 20 years, we're going to look back and say that was the real revolution in the Internet, but the first one was simply a prelude. So what am I talking about? The original Internet, where we connect our phones, a screen. We connect our tablets, it's a screen. We connect our laptops, it's a screen. We connect our personal computers, it's a screen. We connect our TVs, it's a screen. We've connected a lot of screens to the Internet and extracted enormous value from moving data, information, exchange across those screens. It's delivered a digital economy that's gone from zero to tens of trillions of dollars in only a couple of decades. And many people, including myself, have made a career out of that business. It's been a fantastic business and a transformational impact on the face of the planet. But at its core, it's been connecting of screens. So if we consider what it might be like if not just the screens were connected, but everything was connected, wouldn't that be an interesting, potentially very interesting transformation for us as individuals, for our education environments, for our social engagements, for our work environments, for the planet, if we could deliver on that transformation? And that's the second revolution. It's first revolution, Internet of Screens. The second revolution is the Internet of Things.
I just checked. It was W.C. Fields that said, don't act with young children and don't act with cuddly animals. My learning this morning is don't give a video to Anne O'D and don't let her hand it off to Naomi Fain. Where is Naomi? I know she's out there somewhere. And the Think Visual folks, because that's what they do to you, and you'll find you have to follow the cartoon version of yourself. So I can only apologize for the real version, and I promise next time we'll do the entire thing in cartoon, right, Naomi? The kind of core message in that cartoon, and hopefully you can all hear it easily, is that it's our contention, those of us in IoT space, Internet of Things space, that in 10 years we're going to look back at this revolution called the Internet and realize that this first couple of decades of it, which have been about connecting screens, have been just the prelude to the piece of the Internet that really matters and that's really impactful, and that's connecting all things. Because while sometimes I wonder about it with my kids, 18, 16, and 14, I do sometimes question whether they do live in screens. I mean, they're certainly attached to their technology. My two daughters go around with an iPhone firmly encased in their left hand. That's the purpose of their left hand. And so by the time it becomes embedded, it's a non-issue for them. It'll just free up their left hand. So I can't wait for the embedded version of this. But they have merged with their technology. It sometimes seems like they live in screens, but of course they don't. They sleep in beds, they drive in cars, they go to school, they get educated in schools, they socialize in cities. So it's still a physical world. We still spend most of our time in here. And wouldn't it be interesting if we could bring the revolutionary change that's happened in the Internet of Screens and bring that to Internet of Things? So that's the contention, that's the offer of IoT. Now, I won't drag you through my current top 20, this keeps changing. But what I'll say, but I'm going to introduce you to a few examples of the top 20. But the key takeaway from Internet of Things is don't believe that it's just hype. It's not hype, it's reality. So I'll show you some specific examples of that reality at a couple of extremes and then some kind of boring business middle. I'll show you some specific examples of it, and then we'll talk a bit about why it's not bigger than it is. If the promise is so substantial, why is it not more substantial than it currently is? And what could we, as a collective in Ireland, it's actually good to see this is not an Irish collective, it's a collective in Ireland, that what could we do in this location to be part of this revolution? In the way that California led the charge on the Internet of Screens, a small geography can be extraordinarily impactful. If you get the culture and the interactions right in that locality, you can make a difference. And it wasn't the United States that drove that revolution. It was a 100-kilometer stretch between San Jose and San Francisco called Silicon Valley that drove that. It's not the big that beats the small, it's the fast that beats the slow. And we have the opportunity in the revolution that's just tipping now called IoT to be part of that fast-moving, small, fast-moving changer. What I'll say about the top 10 is, if you go, or top 20, is it ranges from looking after rhinos and cat doors and car parking through to space exploration and smart cities and smart factories. The spectrum is huge. And so part of what makes it hard to understand IoT is that as a concept, as an abstracted concept, it's applied so broadly that it's very hard to understand what specifically it is. But when it's applied broadly, you can be certain it's just a collection of small things that are interacting. So I'll start with my favorite example of that. This is Kimberly Dixon. She's not the only person who's done this, but she's the first person I've found who did this. So Kimberly, limited amount of software. She did have a bit of software and hardware capability, but Kim had a good friend of hers called Gus. That's Gus on the left-hand side. And when she went to work each day, she'd leave Gus at home, and Gus needed to get out of the place as well as in. So she had a cat flapper, a cat door. And Gus would go in, get his liquid refreshment and his food, and then leave and have a chat with the neighborhood cats. The problem was that the entire neighborhood cats became aware of this golden opportunity that existed behind the cat door. And so what Kim, after a couple of months of installing her original cat door, so it's a thing, it served a function, a couple of months after she'd put that in place, she was arriving home to a very hungry and very thirsty Gus, and to a kitchen that wasn't in particularly good shape. So as is often the case, she started with a problem statement, which is, my idea of feeding my cat is disadvantaged by the fact that every cat knows about it. So she implemented a solution. She implemented it with open source software, with very cheap hardware, Arduino boards, some 3D printed components. She was able to make this thing in the middle. This was the prototype, and actually ended up being close to the final product that she put in place on the right-hand side. And so that door, her idea was to make sure that the door only allowed Gus in, not the entire neighborhood cats. So that was her problem statement, that was her idea. The implementation of it cost less than $100. She did it on her own. And now there are many ways that you could implement this, and those of you who've spent any time in this space will probably guess the route she took, which was an RFID tag on Gus, and so the door would recognize that this was Gus, not some other cat, and open just for him. I kind of liked her two significant upgrades of it. The first upgrade was that she connected Gus to the tweetosphere. So when he arrived into the house, it would announce his arrival, and when he left the house, announce his departure. A little bit more disturbingly, her second revision of her cat door was a very cheap camera that she had inside the house, and it would snap a photograph as Gus arrived in and post it to his Facebook page, of course. Unfortunately, it snapped a shot as he went out and also posted that. But I'm not telling you that this is the most compelling business proposition on the face of the planet, but isn't it kind of cool that she could take an idea and get that physically implemented as a prototype and then bring that to her market cheaply, effectively. The delta between the idea and the implementation of that idea as a prototype or a product and then bringing that to market, those energy barriers have dropped dramatically in the last decade. They have dropped dramatically in the last decade. So what we've watched happen in screens where my 8-year-old started coding at, my 14-year-old started coding at 8 because it's drag and drop, right? It took me 6 years to learn how to get a PC to communicate hello world. Those of you old enough will know what I'm talking about. To get the PC to respond to me or get the compute system to respond to me with a simple prompt. My son drags and drops this stuff. Now, for the engineers in here, is that efficiently written code? Of course it isn't. It's high level. It's higher level, more abstracted than English. You drag and drop Lego-style pieces to construct your code. You cannot syntactically incorrectly code because the pieces of Lego don't fit together to allow you to syntactically incorrectly code. That's the only thing that's hard about coding. So the difference between him having an idea, which unfortunately is usually about blowing stuff up, and implementing that idea on a screen, and then bringing that to his market, which is load it to the App Store or distribute through his through Facebook or through an app store, the energy barriers have dropped dramatically, and that's why we have the digital economy revolution. That's why kids who haven't yet finished their degrees are starting businesses cheaply and effectively, and some of those are becoming million, billion-dollar businesses. The energy barrier between the idea and the product or service, and between the product or service and market, has crashed to near zero in the digital economy, and it's exactly that that's about to happen in the things economy. It's exactly that that's about to happen in the things economy, because Kim can do this for Gus, and I'll show you some other examples, and we can choose to be part of this, or we can watch some other part of the planet make this happen. This is where I've spent most of my career with Intel, a couple of decades. We, as some of you have been out there, and some of you will know, we dig a hole and we pour $5,000 million into that hole, and we call it a fabrication facility, which is why I can, without ego, declare myself a fab guy. I'm sure you already have recognized that anyway. But fab is where I grew up, and in order to build a square centimeter of silicon with 1 billion transistors on it, 1 billion switches that work on it, one of the handful of things that you have to do in order for that magic to happen is have everything in that $5 billion building connected to one another and connected to the cloud, our private cloud, but they have to be interconnected. The machines have to talk to one another and have to talk to control systems, or we can't build this stuff. So I didn't know it, but I've spent my life in an Internet of Things facility. I think probably the most expensive, but I think the most impressive IoT facilities on the planet are fabs. So you've got, on the one hand, Kim solving real physical problems for Gus, and you have high-tech factories like that out in Leakslip that have been in the IoT game for a long time. So like most overnight sensations, they've been around for a long time, right? The ideas are not widely distributed, but they've been implemented in substantial ways for substantial periods. So let me take middle ground. These are sort of boring business examples, but I want to walk you through some specific examples of IoT implementations that we've gone through in the last year.